Hey, welcome to this lesson video for properties of logarithms. More specifically, we're going to look at expanding. So our learning target is to expand a logarithmic expression. So let's start with some generic examples, and then we'll look at some examples that actually have some numbers and different things involved. So first of all, to break up two things that are multiplied within a log. So for example, m times n is within this log. So to break up a multiplication, we can break m and n into their own logarithms by adding log bm plus log bn. Similarly, when we have m divided by n, we can give each of those letters their own log, but we break up the division by subtracting the two logs, log bn. Whenever we have a power, it's a simple rule, just bring the power out in front. So we would have x log bm. The next example is just, actually the rest of the examples are just going to be combinations of those basic three properties. Here I have m and n that are multiplied, but more specifically n has a power. So I'll take baby steps. I'll break up the multiplication first by adding the two logs together. But I'm not done because this n has an exponent, so we just have to bring that power out front. So we'd have log bm plus x log bn. Okay, and this here would be the final expansion. Likewise, we have division, so we'll first break up with subtraction. Okay, but then go back and notice that one of my logs still has a power, so that first one, I need to bring the x out front. So I'd have x log bm minus log bn, and this would be my final expansion. Right. Next up, we've got this root house here. Now, off to the side, let's have a quick recall. Okay. Earlier in the year, we talked about if I had, let's say, fifth root of x cubed. We talked about rational exponents, meaning exponents that were fractions. We could get rid of root houses by making fractional exponents. And here's how we could do that. We just need to remember the rule, power over root. Okay, so between the 3 and the 5, 3 is the power, so that would go on top of the fraction, and fifth was the root. So we would say x to the 3/5 power. Also, we talked about, well, what if the power is missing? And I wanted to convert this to a rational exponent. Well, there's just understood to be a power of 1 when that's the case. So y would have the exponent power over root, so 1/4. Finally, one more thing. Oh, let's go back to an x. What if there's no number, no root signified in my root house? Remember, it's understood to be a square root, so there's a 2 for the root. So we would say, if our power was 3 and our root was 2, we would say the power was 3/2. Okay? So this was an aside to help us with this next example. First thing we want to do is get rid of the root house by making it an exponent. So it'd become x over r. And the reason we do that is because we know how to handle exponents. They just come out front. So x divided by r log bm. Now here are just a few kind of like real examples, if you will. They've got some numbers in there. This would match up with block or example A1 if you have one of our note sheets, because we have two things multiplied, 8 times x. So we simply, to expand it, we break up with addition. Log 2 8 plus log 2x. And we're only concerned about expanding right now. Again, if you're following along with the notes that we're taking, example B matches up with example A2, alpha 2. Okay, so we have the multiplication that we can break up with addition, but then we kind of have to step back a minute and realize, oh wait, x has a power, so this power of 5 has to come out front. Now, if you kind of can catch the pattern, if you can jump straight to this last step, that does not bother me. Okay, you don't have to show me that middle step. Okay, and that would be my final expansion. This example matches up with B2, Bravo 2. We've got division, so we know that we have to break up the two logs with subtraction. But one of our logs still has a power, so we're going to have to move that power out front. More specifically, this power of 2 is going to come down. So 2 log 4x minus log 4y. Okay, and that would be my final expansion. Example D, hopefully you remember that was that last one we did, Charlie 2, C2 if you will. First thing we want to do is get rid of the root house by making a rational exponent. Power over root means the power should be 7 over 4. And then we know how to deal with exponents, we just move them out front. So we simply have 7/4 log 3x. And that would be my expansion. Okay, so we just have a few more examples to look at. We're going to kick it up a notch. A3, alpha 3, this is a lot going on. We've got multiplication in the numerator, one of those things has a power, and then we also have division. So take a look what happens. Log BM plus, and I'm just going to go ahead and bring this power out, x log BN. Okay, so I broke up the numerator with addition, and for the sake of time, I went ahead and brought the power down in front of the log base B of n. Okay. Now, I've got this division bar, so that means subtraction, so we're actually going to subtract this log BP. And that would actually be the final expansion. Now this example, I've got a power in the numerator, and then I've got two things being multiplied in the denominator. So take a look what happens with this one. I'm going to just go ahead and bring the power out front with that first log. So x log BM. Now we know to subtract log BN. Now if you've played euchre, here's a connection, maybe kinda sorta. You might be tempted to add log BN plus log BP. However, because it's at the bottom of a fraction bar, the division is actually going to trump the multiplication, and I am to subtract both log BN and log BP. So the division trumped the multiplication. Okay, and that would be my final expansion. This guy, we've got some multiplication, but then we got that root house. So here'd be my first suggestion. Make each of these rational exponents. So x over r and y over r. And then we're just simply going to break up the multiplication with addition. But actually, I'm just going to go ahead. Each of these, we're going to have to, move the power when I write each of these logs. So I'm just going to go ahead and bring these powers out as I do the expansion. So x over r comes in front of log BM. Since I'm breaking up multiplication, I'm going to add log BN, but again, I'm just going to go ahead and bring that power out front. So y over r log BN, and that would be my final expansion. Just a few more examples. Hopefully you're catching on. We're going to break up the numerator. Since it's multiplication, we're going to break it up with addition, so log BN plus log BN, but n had a power, so I'm just going to go ahead and, bring it out front when I write this expansion. Now p is at the bottoms, meaning it's being divided, so I have to subtract log BP, but P had a power, so I'm going to do the same thing. I'm just going to go ahead and bring it out, and then that way my expansion will be done. All right, with this example, I'm going to go ahead and bring my power out in front of that first log. So I'd have x log bm. But now we have two things in the denominator, but remember the division trumps that multiplication. So when I write each of these logs, log bn, I'm going to subtract them. So I'm going to also subtract log bp, but p had a power, so I'm just going to go ahead and bring out that power of z. So then that way my expansion is done. Okay, one more generic one to look at. Same thing on this guy. When we've got that root house, I'm going to, so we're going to have m to the x over r power, because remember power over root, divided by n to the y over r. And so then just two things. I'm going to break up with subtraction, and then I'm going to bring the powers out front. So I'm just going to do them both in one foul swoop. I'll have log bm, but in front of him goes x over r, because the power comes out front. I'm going to subtract because of the division. And then my log bn is going to have y over r in front. And that would be the final expansion. Okay. So some examples demonstrating those last few properties we looked at. This example E would match up with alpha 3, A3, if you're following along with our notes. So what would our expansion be? Log 2, 4, and then I'm going to break up that multiplication with addition, plus log 2x, but in front needs to go a 3 since x had a power. Okay. Since 3 is divided here, we're going to subtract log 2, 3. And that would conclude my expansion. This last one is the last example we just did, Charlie 4. Okay, we're going to make these guys have fraction exponents. So x to the 6/5 power and y to the 8/5 power. We're going to break up with subtraction and move the powers out front. So log 3x, but in front's going to go 6/5 because of the power, minus because of the division, log 3y, but in front is going to go 8/5 because of the power. So that's my final expansion. Just a couple more. This last one matches up with alpha 4. Okay, so we're going to break up the multiplication on the top. Log 5, 2 plus, power is going to come out, 3 log 5z. Division means subtraction, minus, power comes out, 2 log 5y. And then my last one here matches up with Charlie 3 in the notes, C3. So first thing first, get rid of that root house by making them fraction exponents. 3/4 for x and 2/4, which I'll reduce in a second. Whoops, I said fourths, but I wrote a 5. Way to go. There we go. Okay, so since x and y are multiplied, we're going to break up with addition. Log 7x. 3/4 comes out front though, plus log 7y, but the 2/4 comes out front, and I'm just going to go ahead and reduce that. 2/4 reduces to a half, so that would be my expansion. Okay, so that concludes this lesson video for expanding. Keep learning, guys, and have fun. I'll see you next time.